Today we're going to be looking at how we add fractions together. Now these use the skills that we've been using on Monday and Tuesday. So that's looking at equivalent fractions and that's looking at simplifying fractions. I've got 2 questions per board and I've got 4 boards because there's lots of examples, but the good thing is that it's the same idea for every single one. Important rule number 1. Always work down the page and try and keep everything underneath its partner from the above line, and that way it makes it a whole lot easier for yourselves. Okay, so the first thing to realize is that we can't add thirds and quarters together. So we have to change them into something that is common to both of them. So I am going to change both of these fractions into twelfths, because I know that 3 and 4 both divide into 12. So this is now similar to the work on equivalent fractions. The only difference is that we're now working down the page, but when you worked on equivalent fractions, we worked across. It's exactly the same idea. You're comparing the 3 with the 12. And you say, what do I multiply 3 by to get 12? And the answer is 4. So what you can do to help you, if you want to, is you can write down a times 4 there, which means that really then we need to write a times 4 there. So that gives me 8. Okay, then I do exactly the same here. What do I multiply 4 by to give us 12? The answer is 3. So I write a times 3 there, which means I need to multiply that by 3 as well. So that gives me 9. So now when I come to do this, this is the important part. I add the numerators together. So 8 add 9 is 17. And my denominator stays as 12. I do not add those together. That stays as 12. Now, this part is probably the next trickiest part of the question. If I'm talking about twelfths, a whole 1 in terms of twelfths is the same as 12 twelfths. That means if I take 12 out of this 17, I'm left with 5. So that's the same as saying 12 twelfths and 5 twelfths, because when I add those two together they give me 17. But 12 twelfths is the same as 1. And then I just write the 5 twelfths there. Okay, so remember that for any fraction to be represented as a whole, the numerator and the denominator must be identical, and then when you've taken that 12 out of the 17, I'm left with 5. Okay, you can always rewind the recording and listen to that again. Right, when we move on to this one, it's exactly the same idea. I need to find a number that 2 and 7 both divide into. I know that is 14. So that means I'm changing both of these into 14ths. So what do I multiply 2 by to get 14? The answer is 7. So that means I need to multiply the 1 by 7. So that gives me 7. Okay, here 7 times 2 gives me 14, which means it's 3 times 2. 3 times 2 is 6. 7 add 6 is 13, and it's all over 14. Remember, you add the numerators but not the denominators. And because this numerator is smaller than the denominator, I don't do anything else. I just leave it like that. Okay? So, on to the next one. Here we have 3 fractions. Just because the number of fractions has got bigger, it doesn't make any difference as to how we work everything out. Okay, it's exactly the same process. I look for a number that I know all denominators will divide into. Okay, and again, look, I'm keeping everything in line, working down the page. Makes life a whole lot. Great, thanks. Sorry, Sam, we've got to start all over again. Hold up here, sweetheart. Oh, thanks, Rach.